Hello, 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 hello,
Yeah,
hello,
hello. Yes,
hello,
you're there. Can you hear me?
hello,
Can you hear me?
hello, 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 hello,
Yeah, we can hear you.
hello, hello. Hey, I can hear. Hello. Okay. Hello, everyone. This is Ankit. I'm an open source contributor and a blockchain enthusiastic. I'm a consultant of a blockchain and Ethereum technology right now. Along with me, there is Mr. Dash, who is a blockchain consultant. He's a blogger and a tech person. He is also working on the blockchain domain. So let's start with the blockchain technology. So yeah, this is something the most important part, the disclaimer part. All the contents in the presentation or any link related materials such as videos, emails or other related services is provided as information only and shouldn't be constructed as investment advice. All the contents, including potential advertisements, social media communication, or other such materials, shall not be constructed as a recommendation to buy or sell cryptocurrencies. Let's start with the blockchain intro. We'll give a quick highlight of the blockchain technology and the Ethereum technology. So, what is actually a blockchain? Blockchain is a glorified linked list. We can say it is a glorified linked list. A blockchain is a distributed database that maintains a continuously growing list of records called blocks secured from or tampering and revision. Each block contains a timestamp and a link to a previous block. So, I mean, take an example how actually the blockchain works. Suppose you are sitting in a classroom and there are around 100 students and each one have their own laptops or system. Each laptop is connected through some network where one can see the data presented of the other laptop, I mean, other guy laptop. So from one laptop, we can retrieve the data of the other system. I mean, all the systems should be connected in a concurrent way. So this is the overview of a blockchain technology. So let's move to the next slide, please. So what is actually a Bitcoin? Bitcoin is a distributed, decentralized digital cryptocurrency that relies on blockchain technology. So I think Mr. Das will give a more brief intro on the Bitcoin. That will be much helpful. Mr. Das, can you give a brief intro on Bitcoin, please?
Thanks, Ankit. So I am today just explaining about Bitcoin. So Bitcoin was one of the first cryptocurrencies which started with the whole concept of trustless consensus or in a decentralized format. So the key aspects of Bitcoin is that it is a cryptocurrency based on digital signature where the different nodes act as timestamp servers, which basically based on where each of the transactions that are added to the blockchain by any user who has to send one Bitcoin from one user to another, he broadcasts that to the overall network, and there are miners who would validate it and add it to their into the block, and the a chain of blocks is what you call blockchain, and that is what is managed by all those distributed Bitcoin nodes that run since last so many years. So it was started in October 31st, 2008 with the Bitcoin white paper, and is sometimes is credited with being one of the first proof of work cryptocurrencies, and one of the most popular cryptocurrencies right now in existence. So I'll just pass on to Ankit to explain more about Ethereum. Go ahead, Ankit.
Yeah, thanks, Mr. Das. So let's talk about the Ethereum. What is actually Ethereum? After the existence of the Bitcoin, there comes a platform called as Ethereum. So Ethereum is a blockchain based. Yeah,
Yeah, you can proceed.
so in Ethereum, Ethereum is a blockchain based distributed computing platform, okay, which is smart. It provides a decentralized virtual machine that can execute peer to peer contracts using a concurrence called Ether. So let's move to next slide. This is how the actually now the bank model works in current scenario. See, here we can see that if a person want to send the money to person B, he has to first deposit that much amount of money in the bank, and bank will verify whether that person possesses that much amount of money or not. If that person possesses that much amount of money, then only the further transaction got happen. Here bank plays a centralized server kind of a thing. They are the centralized authority, and in the worst case they can freeze your account also. I mean, if I mean they have the central authority. They know how much money you own, and they know every each and every transaction detail you are doing. So here bank plays a centralized role. So let's move to the next slide, please.
Okay, so to add
Yeah,
on to
this is how the blockchain works. Here in the blockchain part we can see, here the counterparty A sends wants to the fund to the counterparty B. The transactions is
go ahead.
yeah, Mr. Das, please go ahead.
Yeah, just to add on to the previous slide, here what happens is that in banking system,
Yeah, Mr. Das,
bank,
you can
the
add please few insights in this part.
yeah. So the banks provide as the central authority, or you can say we have to trust. We need a trusted mode of transaction in case of the existing financial models, and that is what is quite shown in this particular slide. And this is what is currently Bitcoin or Ethereum blockchain is all about. And the trustless part of it is what Ankit would be explaining now. Yeah, go. Please, can go ahead.
Yeah, here the I mean in the blockchain, what's actually the blockchain? The blockchain is a distributed public ledger, which is most commonly known as a core underlying technology for the, I mean, in any coins or you can say tokens. There are two parties. party one, I mean, we can call it as a person and the person B. Suppose person A wants to send the some money amount of token to the person B. So how are they gonna do? They will put that much amount of money in their wallet, and their wallet has a certain fixed, I think there's some 32 digits, which is anonymous to everyone. I mean, nobody can know who own that address until or unless that person will tell that yes, this address belongs to me. So when the person A wants to send the person B, then he has to put that amount of money on the. Can you move to the next slide? I can discuss it from there much better. Yeah. See here, there is a Alice girl. She has created a BTC wallet, and this wallet has a unique address. So she will buy the BTC from US dollar or INR. Next slide. She wants to send the money to the Bob person. So Alice wallet need a sign of the transactions. So whenever she wants to send, she has to put that much amount of money on the network so that it will go to that Bob wallet. And to validate all these transactions, here the miners comes into the pictures. So miners are the people who collect all the transactions. I mean, they somehow solve the computational graphic puzzle, mathematical puzzle, and the person who will solve the puzzle first, they are, I mean, they will get rewarded with the mining fee. This is how the mining works. So when the person A sends that amount of money to the person B, so in every transactions, a new block is sent out on the network. Other nodes validate whether that is valid or not. There is a rule of something called as 51% rule, where I mean, the minus will, the group of a miner, 51% group of a miner will validate that transaction will happen or not. So each coin, or you can say each token, have their own, I mean, this rule, consistency rule. So this is what the proof of work is actually. In proof of work, there is someone, I mean, there are miners who gonna validate the transactions. So currently, Bitcoin or the Ethereum, both are working on the proof of work. In Ethereum technology, people are thinking to move it on the proof of stake part. So, Mr. Das, can you give your few inputs on the mining also?
Okay, so we have to understand the history about mining and why it was considered as a way ahead, or was incorporated as a way for validating transactions in Bitcoin. Previous to Bitcoin, also there were certain cryptocurrencies like Hashcash, which have failed because they either depended on the central on a trusted mode of transaction, or there the because of that 51% attack, people believed that there was a need for or Satoshi felt, and that at that time there was a discussion on the need of finding a way in which to secure the network using the network itself. And to do that, the general approach was how one can show the proof of something that has been done. And the best way was to do some calculations on a computer. And the general approach that was agreed upon is or was for Bitcoin was using SHA-256. And the kind of algorithm that is used, that is ECA, elliptic curve algorithm, it has certain symmetric properties which makes it unique in the way that somebody who may not can decipher the whole private key, but using the Merkle tree, they can get to the best possible result. And using that concept, along with the way of as the way of validating transactions, mining works. And that is pretty much all the kind of mining that is currently available, not only for Ethereum, not only for Bitcoin, but other altcoins, script-based Litecoin or Ethereum as well. And the general approach is that you what you call whenever there is a new mining happens, a new block is generated, and the general way they do it either using GPUs, or there are certain coins that can be done with CPU mining, but they are less secure because of the algorithm they use. But generally, the AIC miners or SHA-256 is being considered the most secure till now, which has not been broken. Okay, I'll pass on to you now to blockchain apps. Yeah, you can.
I think people are unable to see the slides. Can you please
One second, one sec. Can they see now? Yes, they can. Okay, it's taking. Yeah,
yeah, it came. No.
yeah, you
Sorry
can.
for the inconvenience. So, yeah, yeah. So now, yeah. Anyways, the slides will be available on the LinkedIn slideshare, or the link will be given below this crypto byte. You can download or you can see all the slides. So, anyways, so in the we're gonna talk about the blockchain, Bitcoin, and Ethereum part. So the blockchain.
Uh,
So previously, the technology which we were working on mainly on the hardware, or you can say the OS part, that was something like a core technology. And after that, the system called as some specialized purpose app. We got into the mode where we generally make the app for a specific purpose, and they are usually in the centralized way. Suppose, we are making the WhatsApp for messenger service, Facebook for the social networking, Quora for the blogging, or for QA and answers, Bitcoin for only for the digital transactions, Ripple for the bank transactions. After that, the technology come was Ethereum. Ethereum, Ethereum is a technology which works on the distributed platform. What is distributed platform? We're gonna discuss in our next slides. So, to give a brief intro, okay, let's move to the next slide. There are usually three types of network: centralized network, decentralized network, and distributed network. So in centralized network, there is one master node and there are other slaves nodes. One master node is connected to each of the slaves nodes. If the master node goes down, the whole server thing will go down, right? Now let's come to the decentralized system. What is actually a decentralized system? In a decentralized system, there is a distribution of a load, and it's more on the technical architectural level. Here you can see, it's divided into the submodules, small submodules. If the one master of the one submodule goes down, the peer of that group will automatically go down, but it will not affect the whole network, just like in the centralized system. But let's come to the non for the in distributed system. There is a concept of a peer-to-peer node, or you can say peer-to-peer networking. Here, no server owns the particular model. There is no centralized authority kind of thing, and it works basically more on the functionality level. So Ethereum is actually a technology on which the distributed apps are being made. So there is a site called the DApps where you can go and see the application which are being made on the Ethereum technology. Just like we have a Google Play Store where we put our Android apps. Similarly, there's a DApps where we put our the tokens which we made on the Ethereum platform. So it's a very good. You can go and explore the more about it. Mr. Das, will you please give a little bit input on this from your side? It will be much helpful.
Okay, so just to add on to what Ankit said, is that distributed works best. If you see the underlying architecture of all network-based architecture or topology, there would be some kind of distribution. Distribution, mostly in kind of architectural sense, is used to share load. But in case of a decentralized architecture like internet or we can say Bitcoin, the approach is that they want to avoid a single point of failure, and much of the transactions or exchanges happens peer to peer. It's also the same with distributed, but in distributed, the idea is to decrease the load of traffic that is coming to either to a network or to a system, and to just share either in a co-located environment like in a data center or across data center. But in case of a decentralized architecture, the approach is that there is no central point of failure, and mostly the transactions would happen between two parties. And in ways that dApps leverage this kind of decentralized architecture to create decentralized applications. While earlier there were a lot of ways in which decentralized applications were created, but thanks to Ethereum now a full architecture starting with Ethereum as the core layer, smart contracts, and then wallet APIs to directly contact to store procedure. These smart contracts, you are able to run a full dApp. So in effect, a dApp can run from your local PC without hosting that, but it can be a web page which can be on your local PC. It can be also hosted on a website, or after the introduction of ENS and Whisper and IPFS, probably you may not even need the traditional stack of DNS and others that are associated with the centralized architecture. So that is from my end as far as understanding of decentralized and distributed architecture goes. I will now pass on to you, Ankit, to explain maybe more about the kind of cryptography, why we call cryptocurrencies.
Sure.
Yeah, go ahead, Ankit. Uh, Ankit, are you there? Yeah.
Okay.
So,
So,
I
I
think
think
I
I
now
now
move to private
private
key
key
and a
and a
public
public
key.
key. So let's
So
start
let's
with
start
a
with a
private key and a
private key and
public
a
key.
public key.
Yeah.
Yeah, 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 yeah.
Uh,
Uh,
so this is how
these
the
things
things
are
are
happen
happen
in
in
the
the
public
public
key and
and
private
private
key.
key.
So
So
there
there
are
are
two
two
keys
keys
in
in
a
a
blockchain.
blockchain.
generally.
generally.
One is a
One is a
private key and
private key, and the
another one is
another
a
one is a
public key.
public key.
Think of a
Think
bank
of a bank
system.
system.
You own,
You
they
own, they
give you
give
some
you some
16-digit
16-digit
account
account
number.
number.
These
This
account number
account
are
number is
something like
something
your
like your
public
public
key.
key. And for each credit card or
Debit.
debit card, you got a PIN code, which you are not supposed to share with anyone. This is like a private key of your account. So from your public key, no one can get into the private key, but from your private key, in not in a bank, but in blockchain, from your private key, one can go from your private to public key. But from public to private, it's not a, I mean, it's a irreversible process. Here you can see in the picture, if suppose there is address of a Bitcoin A, and the person wants to go from their public address to private key, he can't go. But from private address to public key, he can easily go. So can we move to our next slide? Yeah. So let's start with the Ethereum. Ethereum clients. In our next webinar, we will demonstrate how the Ethereum technology actually works, how to download, and how to run all the Ethereum clients. So before that, I will give you a little bit intro, or you can say overview about the Ethereum. I mean, what is actually the Ethereum and how actually it works. So to work on the Ethereum, you need a few things, just like Web3.js. You need to have a little bit understanding of the Solidity language, and for making the API, you need to have a working knowledge of the API making, whether it's in Go, Python, C++, JavaScript, whatever. So, I mean, there are a few Ethereum clients which you need to go and figure out. Here, the link is given, getethereum.org. And these clients are generally made in the language Go, Rust, C++, Python, or JavaScript. Next slide, please. Yeah. So this Geth is commonly used, whether you are working on any of the Ethereum client, this gonna be used, you will use it. Currently, we are using the version 1.5.3, and this is the largest Ethereum client which is written in the Go language. Move to next slide, please. About 100 nodes. I think we will discuss more about the Geth in the our next webinar. That will be much helpful. I will do the system setup, and I will give the pre-required things which need to be done, and that will be much helpful. Please go to next slide. Yeah, Ethereum and a dApp architecture. What is Ethereum? I think we have discussed. It's just like a platform, distributed platform, where we made apps, distributed apps, the apps. And let's start with the architecture. I mean, what is the architecture of the apps made on the Ethereum platform? Next slide. Yeah, come to next part. The tech component. Tech component. Mhm.
Um, Okay, I'll just quickly touch upon the key tech components as far as dApps are concerned. One is the smart contract. You have to write the smart contract using Solidity. So this is the language that is used, which is the Turing complete language that can be used to write any kind of smart contract. Then you have a Web3 API. Web3 API is mostly the wallet API through which you connect to not only your wallet to the Ether that is there, but also that is what is used to connect with any kind of smart contract, and that is what is also used to submit any kind of transaction and any kind of and generally the browser supported API for it is Web3 JS. So I'll just directly go to the approach how a dApp setup happens. So if you see this side, this is primarily the setup for a private network. But the same can be told about a public network as well. So generally, how the life cycle of a dApp works is that during development, you only develop either first locally using some kind of either you use the web-based ID that comes from Ethereum, or you use it using Geth, or in the and once you have developed your smart contract, you can host it on the test network to test if your dApp is working fine or not. And once this is, everything is fine, and also you have security audited your dApp, then you can move your smart contract to the production network. And for specifically when you move it to production, that is when you would realize the amount of you have to calculate how much amount of cost that would be to host your smart contract in production. So usually how it would be, like, you have a Solidity contract which you compile and you submit it into the network, where in case of the test network, it can be run using test RPC, but in the in the test Ethereum public network, you may follow, you would be submitting it to the blockchain. And then the same goes for the production side of things. And then you may have a JavaScript or HTML based web page through which you can interact using Web3.js API calls, which in turn would have to make JSON RPC calls to get, which is the full node, and that would directly connect with the smart contracts running in EVMs, which is at the miner end. And each time any execution of any step in a smart contract happens, there are two types of steps. One is that consumes certain consumes some kind of uh, 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 gas, which is the transaction cost, or else it doesn't. Okay, so more on that we'll be covering in our next sessions. So now I would just quickly touch upon one of the key areas about consensus. So in case of a distributed ledger technology like blockchain, the importance of consensus cannot be lost. Now, most of the public distributed blockchain networks, for example, you take Ethereum or BitShares or Bitcoin, or for that matter, Waves, any of these public cryptocurrency based ecosystems, they have to have a way of getting that consensus, where a lot of nodes would validate a transaction and would add it to their blockchain. So the general there are three types of there are many types of algorithms, but the general proofs that one follows is proof of work, which Bitcoin, Litecoin, other proof of work algorithms follow, where the miners decide which transaction to add, and the largest chain wins. Then there is proof of stake. Proof of stake have various variants, like least proof of stake or delegated proof of stake. Primarily, that is for setting uh, where at least 10% of voting rights are given to. I mean, based here, there is a voting mechanism based on number of uh, 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 tokens or coins you stake into the network. So in this case, you have to your reputation is based on some kind of a staking algorithm. And there, BitShares uses dedicated proof of stake, and Waves uses something called uh, uh, least proof of stake, and then you have also other algorithms like proof of importance, which is being followed by NEM. So you would find a lot of such algorithms. Again, on the other end, there are private blockchains which follow a different kind of consensus. There, since it's a trusted network, the consensus mechanism would work differently. And some of the good examples are Tendermint, Hyperledger's PBFT, which is a Byzantine fault tolerance algorithm. So basically, that is to prevent that 51% attack on the. Okay, based on the get demos and commands, we would be taking a more detailed session next time. So to get but if you are interested in running, exploring more on Geth, then you can explore these links. The GitHub link is Go Ethereum, which is the Geth client, and then you can download it, and it is basically the full-blown client. So now I'll just touch upon the kinds of wallets that you would find in any kind of a typical a cryptocurrency or a general blockchains, public blockchains. So one is a full node. A full node is what something like Geth is, where you the entire blockchain for that network would be kept on your hard disk, and that particular that is the interface. That full node is the interface to the whole blockchain network, and through that you either would be sending your transactions or receiving your transactions into the blockchain. And then there are mining nodes. Mining nodes are the one that verify the transactions, either through proof of stake or through proof of work. And then there are the master node concept, but that is for a discussion for a separate time. And then finally, the most important, the one that general users like you and me use, are known as light wallets. Light wallets are nothing but web-based wallets or app-based wallets through which you actually interact some of these full nodes using JSON RPC API calls or through various services. So if you have ever used something like IAM token or my Ether wallet, these are some of the light wallets that directly talk to one of the full nodes, for example, Get or Parity or Mist. So from here, I would just thank you all for joining this session. I know there have been certain glitches which we will be improving in the next session. I'll be just taking quick questions now, if there are any. Uh, so let me just quickly have a look. All right. I'll just wait for a minute or two, and you can also find the link to the specific uh, video which we have shared in the footnote below. So just to show you, I'll just I'll just show the where you can probably find the so here if you go below you can find the so here you may find the link to the specific uh, presentation that we showed today. And okay, nice for asking about fork. So just to explain what are forks. Forks are basically a way in which a system upgrades. So you have a blockchain, and a blockchain is basically a way in which in a general software, when you have to upgrade something, you send updates. But in case of a distributed network, it is not that simple. You have to have in case of a blockchain network, the consensus work differently. There is a concept called economic majority, where the economic majority is mostly about the miners in case of a proof of work system, or the stakeholders. So there has to be some kind of voting. And in case of if you see Bitcoin or even in case of Ethereum, the general approach is that when at a given specific block, if there is this much percentage of miners who support it and users accept it, the fork goes. That's why you would see that some of the forks that happened in 2017 in Bitcoin were contentious because, for example, SegWit. Because the problem was that there was no consensus. But on the other hand, this year, when you see the Metropolis fork that happened, which is phase one of the key for forks from moving from proof of work for Ethereum to uh, um, to a proof of stake kind of consensus mechanism. There, everyone agreed, and the network agreed that it is good under the influence of Vitalik Buterin, that this is the way to go, and that's why it went smoothly. But what we are seeing in SegWit upgrade and also SegWit 2x, there is a way in which when you don't have consensus in a network, how a fork can be a very dicey situation. In worst case, there would be a chain split. How the chain split happened for Bitcoin Cash or Bitcoin Gold. And in SegWit 2x, people say it is kind of a 51% attack. 51% attack is a way in which the existing network is not allowed to use is not allowed to use the blockchain, and they effectively lose the control over the blockchain. And if they have to be part of the overall blockchain network, they have to upgrade the software. That is the rough idea about SegWit 2x. Probably I'll be explaining more about it maybe tomorrow or over the weekend in a separate video. So this was our introductory video. Thanks for joining. Unfortunately, I have this much time, and apologies for all the last minute glitches that have happened. Though I will try to make it a more interactive and also a more well planned session in future. Thank you very much.